Okay, let's start acid, bases and salt. The chapter 5. We have learned about acids and alkalis in previous classes. In that, we have studied different methods to identify them. The different methods are litmus, phenolphthalein and methyl orange. Then we can discuss acid, bases and salt in coming section. Before that, we can look the characteristics of substance given in the table by using litmus paper. Okay, we can look substances, changing color of litmus and characteristics. First substance is vinegar. What happened to vinegar if it is dipped by litmus paper? Here, blue litmus paper turns to red. Blue to red. Then lime water. Red turns to blue. Red to blue. Then soap solution. Also red to blue. Then hydrochloric acid, blue to red. Therefore, characteristic is first vinegar is acidic. Lime water is basic because it is blue to red, therefore acidic, red to blue, therefore it is basic. Then soap solution is also basic. Hydrochloric acid is acidic. Next we can say acid react with reactive metal to form hydrogen gas. For example, when acid react with zinc, that is acid is taken here is HCl. Then Zn plus HCl give ZnCl2 plus H2. Therefore, we can say that when acid react with reactive metal, it generate hydrogen gas. Similarly, when acid react with carbonates, carbon dioxide gas is liberated. For this reaction, a experiment is given in a textbook. That is, we are taking a small piece of zinc in a test tube and we are adding 2 milliliter of dilute hydrochloric acid using a dropper. Then showing a burning matchstick at the mouth of the test tube. Then we have to record the observation. So, by that experiment, when zinc is added to HCl, we will get ZnCl2 plus H2. So, due to liberation of hydrogen gas, when we show a burning matchstick, it comes with a pop sound because hydrogen gas liberated is burned. Similarly, when acid react with carbonate, carbon dioxide gas is liberated, that we are told. To show this reaction, there is another example in textbook, that is take some calcium carbonate in a boiling tube. Add dilute hydrochloric acid to it through a thistle funnel. Pass the evolving gas through a clear lime water taken in a test tube. Then it is asked that which gas that come out through the delivery tube. That is, we got carbon dioxide gas. That is, during this experiment we will get carbon dioxide gas. Then what is your observation when this gas is passed through a clear lime water? When the carbon dioxide gas pass through clear lime water, it turns milky. The clear lime water turns milky when carbon dioxide pass through clear lime water. So, we can look characteristic of acid. There are 4 characteristics for acid. First, it turned blue litmus to red. Acid turned blue litmus paper to red. Then acid react with carbonate to form carbon dioxide. Any acid which react with carbonate, it form carbon dioxide. Then it liberate hydrogen on reaction with highly reactive metals like magnesium and zinc. When acid react with highly reactive metals like magnesium and zinc, it liberate hydrogen. Then acid have sour taste. Okay, next we can look common component of acid. I will write some examples for acid like HCl, HNO3, H2CO3 and H2SO4. This is hydrochloric acid, this is nitric acid, this is carbonic acid and this is sulfuric acid. Then we can ask which component is responsible for common properties of acid. We can see here in this all type of acid there is one common component, that is hydrogen. Hydrogen is the common component in acid. Next we can look when hydrochloric acid, that is HCl, dissolved in water, a formation of oppositely charged ion takes place, that is HCl gives to H plus Cl minus. Similarly, nitric acid HNO3 form to H plus NO3 minus. Therefore, we can say ions present in HCl is H plus and Cl minus. Similarly, ions present in HNO3 is H plus and NO3 minus. Then we can say common ion in both is H plus. Therefore, we can say that properties of acid are due to presence of hydrogen ion present in them, that is H plus ions. Hydrogen ions means H plus ion. Therefore, we can define acid as substances which can increase the concentration of hydrogen ions in an aqueous solution. That is, acid are the substances which can increase the concentration of hydrogen ion in an aqueous solution. Since H plus ion does not have independent existence, they combine with H2O molecule and form hydronium ion, that is H3O plus. This is called hydronium. That is H plus is combined with water molecule, that is H2O molecule, then it form hydronium ion, that is H3O plus. In our daily life we use some low concentrated acid like lime juice, curd, tamarind, vinegar, etc. That is, citric acid is present in lime juice, lactic acid is present in curd, tartaric acid is present in tamarind and acetic acid is present in vinegar. These acids are in low concentration and we can use in our daily life. But all acids are not to be tasted. Mineral acids like HCl, that is hydrochloric acid, sulfuric acid, that is H2SO4, nitric acid, HNO3, etc. cannot be tasted. These are strong acid. Now consider chemical equation. HCl gives H plus Cl minus. In this equation, how many hydrogen ions are released when one molecule of HCl is ionized? The answer is 1. Here 1 hydrogen ion is released. Therefore, we can define basicity as the number of hydrogen ions that can be donated by one molecule of an acid. I repeat, basicity is the number of hydrogen ions that can be donated by one molecule of an acid. In the above equation, basicity is 1 because here one hydrogen ion is released. Therefore, it is said to be monobasic acid. That is, monobasic acid means its basicity is 1. Similarly, in the ionization of nitric acid HNO3, it gives H plus NO3 minus. Therefore, its basicity is 1 because 1 H plus ion is released. Next, we can look chemical equation for ionization of sulfuric acid, that is H2SO4 gives H plus HSO4 minus. Then again HSO4 minus gives H plus SO4 minus. Here in this reaction 2 H plus ion is released. So we can say its basicity is 2. If basicity is 2, it is said to be dibasic acid. Dibasic acid are explained. If basicity is 2, then that acid is said to be dibasic acid. Next, look the reaction H3PO4 react and form 3H plus PO4 3 minus. Here 3H plus ions produced. Therefore, basicity is 3. If basicity is 3, it is said to be tribasic acid. That is, we have learned monobasic, dibasic and tribasic. If basicity is 1, it is monobasic. If basicity is 2, it is dibasic. If basicity is 3, it is tribasic acid. Next, we can look some examples for monobasic, dibasic and tribasic. HNO3, HCl are the example for monobasic. H2CO3, H2SO4 and H2SO3 are example for dibasic, and H3PO4 is the example for tribasic. Next, consider the equation H2O plus CO2, which gives H2CO3. This is carbonic acid. This carbonic acid is familiar to us, that is, it is soda water. So we can say carbon dioxide is dissolved in water to make soda water or carbonic acid. Similarly, when SO2 is dissolved in water, it forms H2SO3, that is sulfurous acid. Therefore, CO2, SO2 and NO2 are non-metallic oxide. Generally, compounds formed by reaction of non-metallic oxide with water are acidic. That I have explained here. CO2, NO2, SO2 are non-metallic oxide. These non-metallic oxide react with water and form acidic. It forms acidic. Next, we can define acid rain. In industrial areas and townships, the chances of air pollution are very high. In such region, gases like SO2 and NO2 reach the atmosphere in larger amount. These gases dissolve in rainwater and reach the soil as acid. This is known as acid rain. Next, we can discuss some environmental problems caused by acid rain. First, plants lose their ability to produce carbohydrates through photosynthesis because their leaves are destroyed. Severe acid rain destroys the greenery of a region. The acidic nature of water causes death and destruction of fish and corals. These are the environmental problems. Next, we have to discuss measures to take against environmental issue by acid rain. First, reduce the excessive use of fossil fuel. Second, before using fossil fuel, remove sulfur compound from them. These are the two measures to take against environmental issue by acid rain. Next, we can discuss what is alkalis. Metallic oxide generally exhibit characteristic of bases. The base that dissolve in water are called alkalis. For example, metallic oxides are MgO, CaO, etc. In textbook, it is given one activity. Burn a neatly rubbed and clean magnesium ribbon. Record the observation. What would be the white powder obtained? The white powder obtained is magnesium oxide, that is MgO. You can write magnesium oxide. Then if we take this magnesium oxide and we add 2 or 3 drops of water, then its nature using litmus paper is it turns red litmus to the blue. Therefore, we can say MgO is alkaline. The reaction is shown in figure. MgO plus H2O gives MgOH twice. Now we can write some chemical formula. NaOH. This is sodium hydroxide. Then CaOH. This is calcium hydroxide. then NH4OH. This is ammonium hydroxide. Next, KOH is potassium hydroxide. These are the examples for alkalis. Can you find out common factor in alkalis? That is OH ion are common factor in alkali. Therefore, if NaOH gives Na plus OH minus, this is hydroxide ion. Hydroxide ion. Also, CaOH twice give Ca2 plus OH minus. Therefore, we can say the common ion OH minus is released when alkali is dissolved in water. Therefore, we can say alkalis are substances which can increase the concentration of hydroxide ions in an aqueous solution. Okay, next we can discuss what is base and alkalis. We can say all bases are not alkalis. The water soluble bases are alkalis. Therefore, we can say NaOH and KOH are example for alkalis. Then AlOH3 and CuOH2 are example for base. Also, we can say NaOH and KOH is example for base also. That is, all bases are not alkalis, but all alkalis are base. Next, we can look some common name, chemical name and chemical formula of some alkalis. First, caustic soda. Its chemical name is sodium hydroxide and chemical formula is NaOH. Next, milk of lime. Chemical name calcium hydroxide and chemical formula is CaOH twice. Then caustic potash. Chemical name is potassium hydroxide and chemical formula is KOH. Next we can see Arrhenius theory. He proposed that any acid or base when dissolved in water dissociate into iron. According to his theory, acids are substances which liberate H plus ions in aqueous solution and bases are substances which liberate OH minus ions in aqueous solution. This is we explained before, that is acid produce H plus ion in aqueous solution, that is when dissolved in water, and base produce OH minus ions when dissolved in water. That is what Arrhenius theory states. Next topic is neutralization reaction. The acid and alkali react with each other to nullify their individual property. Such chemical reactions are called neutralization reaction. The chemical equation for neutralization reaction between sodium hydroxide NaOH and hydrochloric acid HCl gives NaCl plus H2O. Concentration is an important factor in neutralization reaction. Next topic is antacid. We have learned that hydrochloric acid helps the process of digestion in the stomach. So, but an increase in the acid level result in acidity which may lead to peptic ulcer and cancer. So we use antacid. Antacids are medicine used to reduce acidity in the stomach. The chemicals like calcium carbonate, aluminum carbonate, sodium bicarbonate are the main component of antacid. Next topic is pH value. Determination of pH value is the scientific method for finding the acidic or alkaline nature of a substances. It was devised based on H plus ion concentration in solution. We can look pH value for acid, base and neutral. This is the pH scale. pH scale is method used to express acidic or basic nature of substance based on amount of H plus ion present in their aqueous solution. On the basis of pH scale, pH value of neutral solution is 7. The pH value of acid is less than 7 and pH value of base is greater than 7. Here for acid less than 7, for base greater than 7 and for neutral it is 7. Next, pH meter. pH meter is a device used to determine the pH of aqueous solution. Next we can discuss salt. Consider a chemical reaction NaOH plus HCl gives NaCl plus H2O. Here NaCl is the salt formed by the reaction between HCl and NaOH, that is sodium chloride. And we can define neutralization. Neutralization is the process in which acid and alkali react with each other to form salt and water. This is an example for neutralization reaction. Here acid and base react with, that is acid and alkali react with each other to form salt and water. Salt are electrically neutral. The sum of charge of positive ion and negative ion in a salt will be 0. That's all for the chapter 5, acid, base and salt. If you find this video useful, please subscribe my channel, like, share and comment. Thank you.